Studless tires were born from a need to address environmental concerns. As other manufacturers worked on their versions, Bridgestone invested some 500 people, 1/3 of its engineering team, to develop their tires. Bridgestone Corporation began as a maker of Japanese tabi boots. Their split-toed rubber-soled Jika tabi became a huge seller. Later, seeing an opportunity in the burgeoning automobile market, they began making Japan's first tires. 50 years on, the development team wanted to create a non-slip tire that did not produce dust pollution. They reassessed their prior tire-making technologies and decided to start from zero. What causes tires to slip? Ice cubes straight out of the freezer are easy to hold because they are dry. After a few moments, however, heat from the hand melts the ice, making it slippery. The same phenomenon occurs on the road. Heat from friction melts the surface of the ice, creating a thin film of water between the tire and road surface, causing the tire to slip. What does it take to prevent this from happening? The development team looked at a multi-cell rubber compound, a softer rubber with millions of tiny pores. Ordinary tire rubber becomes harder at low temperatures and loses traction with the road. Pores in multi-cell rubber act as a cushion, providing traction with the road. In theory, they thought that water film should not form. But the test drivers reported otherwise.
やっぱり止まらないとか、止まらないもそうだったんですが、走り出せないとかですね、ホイールスピンをしてしまって車が前に進まないとか。
The developers believed the softer rubber should have stopped the vehicle. However, they could not achieve the desired result. In the days that followed, they conducted repeated tests with new multi-cell rubber compounds. The days turned into nearly 2 years. One day, a team member pointed something out.
タイヤって新品だけじゃないよねと。で、摩耗した時のその性能ってどうなんだろうかと。慣らし走行することによって一皮むいてみたんです。
They tested tires that had some mileage on them. The car stopped. The tire's performance improved dramatically. Because tires are molded under pressure during the manufacturing process, the surface of the tread is smooth. Breaking in the tires and wearing away the surface exposed the millions of tiny pores in the rubber. The pores absorb water and allow the rubber to contact the road, creating traction.
これだと。
いけたよねっていう会話はしたと覚えてます。
Could there be a way to make the tires absorb even more water? This led to another idea.
万年筆のペン先を見てたらこれ使えるかなと。ペン先の形状をタイヤに持ち込めないかという。
The properties of a fountain pen nib. When a fountain pen is dipped in ink, the ink is drawn upwards. If thousands of nibs could be put on the tread, even more water could be siphoned away. Applying the concept allowed the tread to draw away even more water and shortened stopping distances. In 1988, after 7 years of development, the world's first multi-cell rubber studless tires were ready. Today, Bridgestone is working on developing new tires with even greater traction and fuel economy. The new rubber compound tires are put to a braking test against previous model tires. Cars traveling at identical speeds apply their brakes at the same point. The new tires clearly bring the car to a stop sooner. Cornering tests show that tires made with the new rubber compound provide traction that is less affected by centrifugal force. Technology from an unrelated industry helped create the quicker stopping tire rubber. Detergent. The technology that detergents use for removing dirt allowed them to successfully incorporate more quick-stopping compounds into their tires. This is the new look of Japanese manufacturing. The challenge of environmental performance transcended even boundaries between industries.